So no problem in the simple linear regression so far, yes or no? Anyone, any doubts?
No,
No,
भैया.
Sure. Cool. So let me begin with asking a few questions. Risha, what is the best line?
the, the best line is the line which has the best question and has the
Wow.
minimum
Rishan,
minimum
क्या पढ़ा रहा हूँ
minimum
मैं
residue.
ऋषा? I think last I was teaching machine learning, not Kama Sutra. Zishan. Vedant, what is the best line?
Sir, the line which best represents the relationship between the data is called the best line.
Relationship between what data? Between dependent and independent variables. Okay.
Yes, B.
Rajdeep, what is the best fit line?
Which has minimum
मैं अगली बार इंटरव्यू में
residual.
होगा जब मुझे सिलेक्ट नहीं होना होगा. Best fit
जिसमें
line is the
maximum
line.
error
हाँ,
कम.
बताओ. Rajdeep, next question. So tell me, Rajdeep, what exactly is a cost function?
जो मॉडल की परफॉर्मेंस को बताता है.
बस वो तो एक्यूरेसी भी
और
बताती है.
इसको इसी को हम लोग डिफाइन करते हैं अलग अलग मॉडल के लिए. जैसे लीनियर रिग्रेशन में ओएलएस था, तो इसमें हम लोग मिनिमम देखते हैं, ग्लोबल मिनिमा. तो
ओके.
जो ग्लोबल मिनिमा आएगा उससे उसका जो
कहानी सुना दी
बीटा
तूने,
वन
पर
था और
पॉइंट नहीं बताया मेरे को. आवाज आ रही ना मेरी?
हाँ भैया.
What is a cost function? Harshita.
A cost function is a mathematical equation which tells about the difference between predicted and actual value. Hello? Hello?
हाँ, आ रही है तुम्हारी आवाज.
अरे मेरा iPad बंद हो गया. So Harshita, what should I do with that? That it's actual minus predicted. I can't do anything with that, right? Or I'm
So
just
we
turning my iPad. Start.
so we need to reduce it as much as possible to get to the equation of the
Why do
best
we need
fit.
to reduce it?
Because it is telling about the difference between the predicted and actual value,
What is
and
that?
we don't want this.
What is that?
That is the error.
So why are you guys not speaking? That cost function is nothing but it represents, and cost function is not the difference between actual and predicted value, right, Harshita? That's residual. Cost function is a function that tells you about the error, and it helps in understanding the performance of model. While learning, or basically when the model is in training phase, the goal of the algorithm is to reduce the cost function as much as it can, basically to reach the global minimum of the cost function. And at that time, we can say that the model has learned perfectly. Yes or no, everyone?
Yes, Priya.
Yes, भैया.
So guys,
Yes,
ये किसी को नहीं बोलते हो, ये कहानियां क्यों सुनाते हो? मैथमेटिकल फंक्शन है, कॉस्ट फंक्शन वो है जिसमें हमें ग्लोबल मिनिमा ढूंढना है, ये करना है, वो करना है, वो करना है. फील क्यों नहीं लेते हो चीज की? जैसे अरे yeah. So guys, that is the importance of, you know, understanding that whenever you guys are studying the theory, you should speak like you're talking to an interviewer. I think it's the millionth time that I'm telling that to you guys. Yes or no? So whoever revised machine learning yesterday from the platform probably didn't do that, and I think none of you did it. And you guys wait कि जब हम रिवीजन करेंगे तो ये चालू करेंगे. But guys, now it's time you do it. Even while you're kind of revisioning only from the notes. You've already seen the lecture once. There is nothing extra in the notes. If there was, I would have pointed it out. Yes or no?
हाँ भैया.
Yes, भैया.
So when will you start revisioning and talking to yourself like you are the interviewer and the interviewee? When it's at the end again, you would do that. So you would waste 2 months again on that afterwards. Or are we smart enough to solve that problem right now along we go? Can you tell me, everyone? And first of all, I'm not liking the silence today in the class. So can we all speak a little?
ये साथ में ही करेंगे क्या?
Yes.
साथ में करना है।
यस भैया साथ में।
Cool then. So I hope you are understanding why I was asking the questions. Not because I wanted to waste time and have fun with you all. I have no intentions to do that. But to explain you that you are again on the same path of not doing what has been told to you. You'll waste your time. Yes or no, everyone? Quickly, there are 26 people apart from me and one from laptop and iPad.
Yes, भैया.
And one
यस
maybe
भैया।
screen share. There are
Yes, भैया.
23 people
Yes,
and I'm not
भैया।
hearing anything from you guys.
यस भैया।
Half of you don't even attend the classes because you think watching the recordings is the best way to go about it. Right? So please, सौरभ को आवाज नहीं आ रही है मेरी, उसको लिख दो.
आगे भैया आगे।
All right. So yesterday, what we did was, what happened yesterday? Yesterday, with the cost function, we calculate the beta naught and beta 1. And after that, we got what? We got the best fit line, right? This is our dependent variable. This is our independent variable. And this is our dependent variable. And what did we get? We got the best fit line, which is having the equation beta naught plus beta 1 and x. Yes or no?
यस भैया।
Yes,
यस भैया।
Yes. And what exactly this is called? We called this a simple linear regression. Why did we call this a simple linear regression?
वन
because there is only
इंडिपेंडेंट।
one independent and one dependent variable.
Yeah, because see, dependent variable, there will always be only one. Okay. There are different algorithms which help you calculate multiple dependent variables. The linear regression does not help you with that. Okay. Those are actually commonly referred as autoregressive regressions. Okay. All right, everyone, is it clear?
Yes.
So it's called a simple linear regression. Why? Because it has one. Clear, everyone?
Yes, भैया.
यस भैया।
Akash, Hardik, Harshita, are we guys sleeping?
नहीं भैया.
Alka, I we all sleeping today? Had a good day and now we're tired. India's playing well. Let's sleep. Let everything sorted in life. Priyanjali, are you sleeping? Rishabh Parashar, Sai Mahesh. Sai Mahesh, you to sleep all the time only. Sujal Gupta, are you sleeping?
नो भैया।
Vipul, I can't hear you. Are you sleeping? Vanisha, Urvashi, are we sleeping today in the class? Is my voice that good that it's feeling like a lullaby? I wish it was. All right. Now, let's talk about simple linear regression. Now, coming to simple linear regression, there is only one independent variable. And because of that, what we did worked. But this will not work in all the cases. Clear, everyone? Can I move forward? So now,
Yes.
to give you and Risha one more closure. So let's say this is my line. I use a new data point comes in, a training data point comes in. What will happen, everyone? So the training data point will have value X, right? And you will put this value X, your X will be somewhere over here, let's say. You will find the value for Y, and this your Y predicted will be the answer. And what is your Y predicted? Y predictor is nothing but beta naught plus beta 1 and this value of x. Clear, everyone?
Yes,
Yes,
sir.
भैया.
Yes, bhaiya.
Yes,
This is how
भैया.
the prediction will work. Clear? Is it clear how the prediction will work, everyone?
Yes, भैया.
Yes,
Yes,
भैया.
Yes,
भैया.
भैया.
Yes, भैया.
Same way it will work for testing data. Same way it will work for validation data. Clear, everyone?
yes, sir.
Yes, भैया.
Yes, bhaiya.
However,
Yes, भैया.
only the errors between actual and the predicted value from here will count towards training, but these errors will not count for that. Clear? These errors will not help the model train. Okay. Clear, everyone?
Yes, bhaiya.
भैया.
Yes, sir.
Yes, भैया.
Right? You're using residuals for this only. You're not using residuals for this, right? Or this, right? So is it clear? Can I move forward, everyone? I think I've talked enough on simple linear regression, and it's pretty. I hope it's pretty clear. Is it, everyone? Yes or no? Can you please give me the confidence so I can move forward?
Yes,
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 bhaiya.
Yes,
All
भैया.
right. So now, what
Yes,
exactly is multiple linear regression?
more than one independent.
Multiple independent variables.
Multiple.
Independent variables.
Good. So, guys, I think we do know what independent variables are. So let's start talking in terms of independent variables or at least independent features, rather than saying more than one variable. ये maths नहीं पढ़ रहे हैं, right? That independent variable and dependent variables are different. So you need to specify which variable is it. Am I clear, everyone?
Yes, yes,
Yes, sir.
Yes,
Yes,
bhaiya.
भैया.
Yes, भैया.
All this is very important, guys. You need to speak like a proper person who understands the machine learning language and not talk like someone who is new to it, right? Hence, I'm pointing it out. So, for example, a multiple linear regression can be and it can have multiple independent variables. Am I clear, everyone?
Yes, भैया. Yes,
Yes,
भैया.
भैया.
Any doubts in this?
No, भैया.
No, bhaiya.
No, भैया.
भैया.
Now, what does multiple independent variables means? Let's understand with a very simple example. How many variables do we have in this?
Two.
पता था,
Three variables.
पता था यही बोलोगे टू.
Three.
भाई तीन
Three
है
है
ना,
ना?
इंडिपेंडेंट वेरिएबल दो डिपेंडेंट, दो इंडिपेंडेंट
अरे
एक
यार.
डिपेंडेंट, सॉरी. पता था यही
हाँ,
करोगे.
भैया.
अभी भी दिमाग में यही है कि ये वेरिएबल होते हैं और ये कुछ और होता है.
ध्यान नहीं रहा भैया.
गलत है ना यार, इतने बार बोल दिया मैंने, सोचते ही नहीं हो, दिमाग कहीं और है. That's not right. So now, what data might this represent? Let's say predicting salary using age, and let's not take age. Let's take maybe the department that person is working in and the work experience in number of days or years, whatever. So over here, my independent variable x1 and x2 will be these two, and my dependent variable would be salary, which is y. Clear, everyone?
Yes,
Yes,
भैया.
bhaiya.
Yes, भैया.
All right. So now let's talk a bit about geometry. So guys, let's take a simple example. Let's say you're predicting the something you're predicting. I can't think of an example right now. This is maybe, let's say, mm, let's say you want to understand whether you should give this person a loan or not. You're working in a banking firm and you want to understand whether you should want to give this person a loan or not. What do you say that x1 is the salary that person earns per month and x2 is the gender of that person? And no, it shouldn't be. It can be should give a loan or not. And why is the amount of loan you can give to that person, amount of money that you can give to that person as a loan. Clear?
Yes, भैया.
What will be the geometry for this, guys? What will be the plot for this?
Three-dimensional plane.
बना के देख लेना पहले. So first of all, everyone, I want to make you understand the gender is male and female. Does model understand male and female? Does laptop computer understand male and female? What is that?
No.
It understands only numbers,
No,
right?
भैया.
So first of all, you can change it in numbers. You can say male is equal to 0 and female equal to 1. Clear?
Yes, भैया. हाँ भैया.
Yes, भैया.
Now think. So x2 belongs to these two. What is the answer, guys?
Is it still multiple regression?
It is a multiple regression. Why do you think it's not?
Because this is coming out to be a straight line.
How can it be a straight line?
Beta 2 is going to be fixed after some iterations.
How are you even solving it without data? Just asking a simple plot for it. Cannot even tell what beta 1 is without looking at the data. How can you even comment on beta 1?
I tried using limits. Sorry.
You cannot say x1 tends to infinity. That's not the case. So guys, your x2 will have how many values? Either 0
2
or 1. Yes or no?
Yes, भैया. Yes, भैया.
Now, let's draw a line from here. Let's draw a line from here. Can I join these two lines and say that the answer is a plane? That means that values these are also allowed. That values between 0 and 1 are also allowed for male and female. मतलब male and female के बीच का भी हम कुछ ले रहे हैं.
No, भैया.
No, भैया.
Hence, what is the answer?
Family of lines.
What is the answer, everyone? अब तो बोल दो.
Family of lines.
Family of lines.
क्यों हंस रहा है सबको? आज किसी का पढ़ने का मूड. आज किसी का पढ़ने का मूड ही नहीं है. बढ़िया. So is it a family of lines? Yes or no, everyone? 2 lines make up a family.
Okay.
Right? यहाँ और भी लोग चाहिए एक फैमिली में तुम लोगों को. I think it's more than enough for it to be called a family, right?
Yes, भैया.
Yes, भैया.
हाँ. समझ आ गई बात? So it is not always a plane, guys. That is what I was telling you the other day, that the geometry of multiple linear regression is not always a plane when it comes to 3 dimensions. It can also be what? It can be a family of lines. Clear, everyone?
Yes, भैया. Yes, भैया.
Yes, भैया.
Yes,
Yeah.
भैया.
And why it can be a family of lines when one of your data is categorical? Let's say there was male, woman, and other. Yes or no? अब 2 बीच में डाल दिया, 1 2 कर लेना खुद से नंबरिंग. और ये भी उल्टी नंबरिंग कर रखी है, ये 0 होना चाहिए, ये 1 होना चाहिए, 2 होना चाहिए. Clear everyone?
Clear, भैया.
Yes, भैया.
Yes,
यस
yeah.
भैया.
Cool. And now these family of lines can be anything. They might be parallel, they might be intersecting. Don't assume things. Rajdeep especially. Clear?
हाँ
भैया.
Yes, भैया.
Yes, भैया.
So for 3 dimensions, if there is one categorical variable, then it becomes what? Family of lines. Clear?
Yes, भैया.
Yes, भैया.
If there is no categorical variable, if all are numbers, then there might be certain some kind of plane, right?
Yes, yeah.
Cool. So now let's understand how do we interpret? Let's say we trained a model. Don't worry, we'll come to training very soon. I will teach you gradient descent afterwards. But before we come to training, let's first understand how we can interpret the model we have learned so far. So let's say you've done the training and you've got the values. It's a 4-dimensional. Yeah, it's a 4-dimensional 4D data, basically 4 variables. One will be your independent and 3 will be your dependent. Sorry, 1 will be your dependent and 3 will be your independent. Now that you have these, your training is done. You've got these values for J minimum, for cost function minimum. Clear? Now let's move beyond and interpret the model. A very important interview question for your entire lifetime. A very favorite question of mine to be asked in interviews. What exactly is this? What do you call this?
coefficient.
Parameters.
Yeah, it's a learnable parameter. It's a coefficient. It's a slope.
Wait.
It's slope in the x1 direction. Right? Yes or no?
Yes,
What exactly is
Yes,
this?
भैया.
How can we interpret it for the model? What does beta 1 tell me? How can I interpret this in terms of model?
So
It tells how important x1 is for the model.
Good. And importance, feature, you reverse it, and this becomes feature importance. Feature importance is basically a way of model telling you how valuable this feature is for predicting. Am I clear, everyone?
Yes, भैया.
Yes, भैया.
yes, भैया.
Am I clear?
Yes, भैया.
So now how is beta 1 telling me how important it is? How is beta 1 telling me how important x1 is? Let's deep down, drill down more. How is beta 1 telling me how important the model is?
भैया, I guess beta 1 shows the weight of feature.
So guys, yesterday we talked something. Very disappointed. All right. So yesterday I said what does this mean?
For a unit change of x coordinate, slope is differentiable.
Slope is telling me for a change of unit in x, or basically the independent variable, slope tells me what will be the change in my dependent variable. Yes or no, everyone?
Yes, भैया.
Yes, we
Yes, bhaiya.
Yes,
Does this
भैया.
apply here? Does this apply here?
Yes, bhaiya.
How?
When you make a unit change in x1, it will give you a change of beta 1 by sigma beta I in the predicted value.
So what you're saying is, what Vedant is saying is, when you make a unit change in x1, then what will happen, Vedant?
It will give a change of beta 1 by sigma beta I in the
What is beta
predicted
1 by
value, that is
sigma
y.
beta I? What is this?
Uh, it's
What is sigma?
basically the weight. No,
What is the
sigma is the
sigma?
sum. Sum.
Okay. So sum of all the
Sum.
beta, you mean? Sum of
No,
what?
like, sorry. Actually, it has to be the magnitude of the unit vector.
So that's
Beta
the
1
problem,
by,
Vedant. This is not geometry.
yeah.
We're not learning geometry here, are we? When there is change of 1 unit on of x1, the dependent variable will change by
Beta 1.
when there is 1 unit of change in x2, the dependent variable will change by
Beta 2.
now this stays intact. Interesting, right, everyone? Interesting, yes or no?
Yes, we.
Yes, भैया.
yes,
क्यों कृष्ण नायक भैया ने नहीं पढ़ाया था? Your favorite? All right. So why? Then that means there is something much more to beta that we are not aware of. Yes or no?
Okay, भैया.
Yes,
Yes,
we.
भैया.
Yes, bhaiya.
What is that? Let me write it. Beta I is the change in the dependent variable on 1 unit in 1 unit increase in xi uh, independent variable because we assume all other terms to remain constant. Interesting.
Yes.
Basically, if this is y1, this is your constant beta naught plus beta 1 x1 plus beta 2 x2 till beta I xi. If I say y2 equal to beta naught, beta 1 x1, beta 2 x2, and beta I xi plus 1, then we assume that on increase of 1 here, there is no increase in x2, there is no change in x1, and there is no change in all the terms till I and after I. Basically, when my xi is becoming xi plus 1, all the other variables from 1 till xi minus 1 and from xi plus 1 till k, all the features will remain the same is my assumption. Interesting.
Yes, bhaiya.
Rest of you, क्या तुम ओवरवेलम हो जाते हो, बोलना भूल जाते हो?
भैया प्रोसेस करने में टाइम लग रहा है इसलिए.
नहीं भैया.
क्योंकि प्रोसेस अभी कंप्लीट हुआ नहीं है. So that means x1 and x1 are same, x2 and x2 are same. So these terms, if I subtract y2 minus y1, y2 minus y1, this is 2, this is 1. So if I do 2 minus 1, all these will cancel out and the remaining will be what? Y2 minus y1 equal to beta I. Xi plus 1 and beta I xi. This will give me beta I xi. This and this will cut. So beta in will be left. Yes or no?
Okay, भैया.
Yes, भैया.
And when does this happen, guys?
When all the features are independent of each other.
Hence the name independent.
Pardon?
Hence the name independent.
Yes, भैया.
Change in xi is not causing any change in other independent variables. Now let me explain you how the change occurs. Let's say you are saying what will be the rent of this house. That is your feature target variable. And your independent variables are length of the house, breadth of the house, only these two for now. So ऐसा होता है क्या कि लेंथ घर की बढ़ जाती है तो ब्रेड्थ उतनी रहती है? कभी ऐसा कर देखा है क्या? बिल्कुल
नहीं भैया. No भैया.
नहीं भैया.
So definitely these variables are not same. These variables are not independent, right? A change in
Yes,
length will bring change in breadth, right?
Yes भैया.
Yes, भैया.
And hence these variables are not good for linear regression. Because when you are interpreting what beta 1 and beta 2 mean, now what exactly beta 1 you are saying? You're saying beta 1 is the increase or decrease. If beta 1 is positive, then increase. If beta is 1 is negative, then decrease. Decrease in y caused by x1. Yes or no, everyone?
Yes भैया. Yes भैया.
But the problem is, now understand the problem. This is the increased one, this is the normal one, okay? I'm taking only two, length and breadth. Ideally, all should cross out,
हाँ भैया.
Yes, भैया.
but the problem is, on increase in length, this is also increasing or decreasing somehow. And hence, your interpretation that beta 1 is increasing or decreasing y caused by 1 unit increase in x1 fails. Your model interpretability is lost. Because if you subtract these two, this is not what the case will be, right? Yes or no?
Yes,
Yes
भैया.
भैया.
Yes, भैया.
Hence, in machine learning, for linear regression, it assumes that the variables are independent. Which variables? Independent variables are actually independent. Clear?
Yeah भैया.
Yes, भैया.
If that is not the case, then you understand how the model interpretability is being lost.
Yes, भैया.
Yes or no?
Yes, भैया.
Yes भैया.
Any doubts, anyone in this?
No, भैया.
No.
Alka, Fardeen, Hardik, Harshita, Isha, Jatin, Jha, Mahesh, Manas, Neha, Priyanjali, Rajdeep, Rajgopal, Rishabh, Saurabh, Sujal, Urvashi, Vanisha, Vedant, Vipul. Any doubts?
भैया. Okay, okay.
No
नहीं भैया.
भैया.
Clear है.
नो भैया.
Cool.
Clear.
So now what is beta naught?
भैया
Yes.
भैया लीनियर रिग्रेशन एज्यूम करता है कि जो वेरिएबल से इंडिपेंडेंट है बट वो एक्चुअल में तो डिपेंडेंट है ना.
तुम्हारा काम है ना उसको इंडिपेंडेंट बना. अगर तुम डिपेंडेंट रख रहे हो तो तुम मॉडल ही ढंग का नहीं बना रहे. पर मॉडल ही इंटरप्रेटेबल नहीं है, बनाने का फायदा क्या है?
बट
कुछ भी बना रहे हो तुम. So guys, is it clear now?
Yes, भैया.
Yes, yes, yes.
हाँ भैया.
So what is beta naught? Beta naught is the change in target feature by 1 unit increase. Sorry, beta one by 1 unit increase in my independent variable x1. Assuming that, important point, assuming that all the other variables remain constant. All the other variables, obviously, अगर मैं बोल रहा हूँ डिपेंडेंट में चेंज हो रहा है बीटा वन का और इंडिपेंडेंट में एक का इंक्रीज हो रहा है x1 में, तो बाकी तो जो बचे वो x2 x3 x4 ही होंगे ना. सो ऑल द अदर वेरिएबल्स आर remaining constant.
Yes, भैया.
Yes, भैया.
Interesting point, everyone. दिमाग खुल गया?
Yes, sir.
हाँ भैया.
Yes, भैया.
हाँ भैया.
Cool. Now, let's understand what exactly beta 1 means. Beta 1 is 10, beta 2 is minus 20. So, what does this mean? That x1, if it increases by 1, then y will increase by 10. Yes or no?
Yes.
Yes, भैया.
If x2 increases by x2 plus 1, and this here, guys, again, don't forget, x2 remains constant.
Yes,
X2 increases to x2 plus 1, then y will decrease by how much?
20.
20 times.
X1
remains constant.
remains
Remains
constant.
constant.
So now understand, greater the coefficient, greater the impact on
Dependent variable.
Prediction.
and
Dependent.
dependent variable, sorry. And
Dependent.
The remaining
the impact will be greater. बड़ा होने का मतलब ये है कि भाई -20 छोटा नंबर है.
नहीं
equal है. Negative again.
Absolute value, guys. We don't care about the direction. The impact, even if it is decreasing, it is impactful. Even if it is increasing, it is impactful. The impact. So if I say that beta 1 is greater than absolute value of beta 2, that means impact of x1 is greater than impact of x2. Yes or no?
Yes,
Direction
भैया.
does not matter,
Yes,
guys.
भैया.
And hence that means feature importance, x1 is ranked above x2. x1 is more important feature and x2 is not as important. And if you want to optimize your model, you can drop x2 if it does not have a good impact. And hence, what are you doing? What are you doing? If feature 2, x2, let's say you have many variables. Let's say you have x1, x2, x3, x4, many variables. You cannot take those many variables to your home. You need to drop some variables. Otherwise, curse of dimensionality will kill you. So now when you have to drop the variables, curse of dimensionality, I'll explain. Basically, as I told you yesterday, that guys, when the dimensionality increases, humans suffer a problem. We cannot imagine things beyond 3D. 4D इमेजिन नहीं कर सकते, तुम जिंदगी निकल जाएगी, पर 4D तुम इमेजिन नहीं कर सकते. ना हम आइंस्टाइन है यहाँ, ना हम न्यूटन है जो 4D हम कुछ इमेजिन कर लिए. ठीक है. So the problem is, as the dimensionality increases, humans face a problem, and so does machine learning face a problem. We'll soon come why machine learning models face a problem. So what happens is, increasing the number of dependent variables increases the number of dimensions. You want to drop the dimensions so that the model does not face a problem. You plot feature importance. You create a linear regression with all these variables. Then you plot beta 1, beta 2, beta 3 till beta 6. You find, okay, I need to keep only the top four. Let's say beta 2 and beta 4, let's say beta 2 and beta 5 are the lowest two feature importance. Let's drop them. So my final model will contain what? Beta naught, beta 1x1, beta 3x3, beta 4x4, beta 5, beta 6x6. I have not taken 2 and 5. And how I'm making this decision? With the help of feature importance. And this process is called as feature selection. Get everyone?
Yes, भैया.
Yes, very.
Yes, भैया.
आगे मजा.
हाँ भाई.
हाँ भैया.
Yes, bhaiya.
Yes, भैया.
मोस्ट इंपॉर्टेंट टॉपिक ऑफ द डेकेड. तुम बूढ़े हो जाओगे, तुम्हारे बच्चों के लिए भी ये तुम्हारा मोस्ट इंपॉर्टेंट टॉपिक रहेगा. अगर वो भगवान करे, वो क्यों यार ये डेटा साइंस करे, तुम इतना पैसे कमाओ, चिल की लाइफ जिए, वो बिजनेस बिजनेस करे, है ना.
हाँ भैया.
हाँ, बना दो लाला उनको घर बिठा के. ये मत बोलना जाके मेहनत करो, अपने दम पे खड़े हो. इट्स नो मोर कूल लुकिंग एट वर्किंग, बेसिकली लिविंग ऑफ योर फादर्स मनी.
भैया
गाइस,
भैया आपने बिजनेस बोला ना, इस पे मैंने हाँ बोला, वो बैठने वाले पे नहीं बोला.
तो क्या करते हैं पापा के बिजनेस पे आधे लोग बैठ के. वेरी वेरी रेयर पीपल एक्चुअली वर्क फॉर इट, एंड आई सैल्यूट टू दोस हु एक्चुअली वर्क इवन दो इट्स देयर डैड्स बिजनेस. मैं तो, मेरे पापा बोलते हैं कर ले मेरा काम, मैं बोलता हूँ रहने दो, मैं बैठा रहूंगा, मैं कुछ नहीं करूंगा. So let me do my own shit, right?
भैया को खुद पे ज्यादा भरोसा है.
हाँ, मुझे पूरा भरोसा है. So it's okay. I can do on my own. When the day, if the day any day I would need, I'll be like okay. But I'm fine. I don't want to work. उनके साथ काम करना, रिकॉर्ड हो रही है मीटिंग, भगवान करे कभी सुने ना हूँ. उनके साथ काम करना बहुत सरदर्दी है. I cannot work with them. All right, linearity. So guys, what are we building?
Linear regression.
What does linear regression do?
It outputs a prediction for a certain dependent variable.
It establishes a linear relationship between the dependent and the independent variables. And hence, the first assumption says that dependent variable is linearly, ये क्यों बनाया है मुझे नहीं पता, is linearly related to independent variables. I mean, it's much obvious, but any doubts?
No भैया.
All right. So what does this mean? Which data does follow kind of linearity?
First one.
First one.
This is kind of x square. This is x. Clear, everyone?
Yes.
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 So linear regression will not work on this data. It will work good on this data. We'll come to how we can make it work. So you understand one of the problem, right? That x square linear regression will fail. Linear regression will give you a best fit line, something like this, which is way far off than the x square. Yes or not, everyone?
Yes भैया.
Yes, भैया.
Assumptions bring problems. And problems bring polynomial regression. All right. What does multicollinearity brings, guys? What is collinearity? What is correlation?
Measure of association between two variables.
So if data is correlated, if x1 and x2 are correlated, what does that mean? If an
Change
x1
in
and
one
x2 are
affects
highly
change in
correlated, what does that mean? Yes, Vedant.
change in x1 affects change in x2.
Guys, that x1 and x2 have a very high strength of relationship between them, and depending upon the direction, the sign of the correlation, if it is positive, then x1 and x2 both increase at the same time and decrease at the same time. If x1 is increasing, then x2 is also increasing. If my correlation is positive, yes or no, everyone? यहाँ हो गया statistics खत्म, भूल गए? What is this nonsense? आगे बढ़ते हो पीछे की भूल जाते हो. If they have negative correlation, that means x1 increases, x2 decreases, and vice versa. Yes or no, everyone? Please don't make me waste my time on this.
Yes, we are.
Yes, we are.
Yes,
Yes,
Bhaiya.
Bhaiya, yes.
Yes, Bhaiya.
Correlation is from -2 to -1. -1 means negative correlation, 1 means positive correlation, and 0 means no correlation. And I told you, and it is also present in the notes, that correlation does what? Correlation establishes not establishes. It measures the strength and direction of linear relationship between two variables. Yes or no?
Yes, Bhaiya.
Yes.
Yes, we are.
What
Yes,
does
भैया.
multicollinearity mean? Collinear? कुछ दिख रहा है? Collinear, linear, co.
Yes, Bhaiya.
Independent variables should not be linearly dependent. Sorry. Multicollinearity basically tells whether the independent variables are linearly dependent or not. Clear, everyone? That is what multicollinearity is. It helps to tell whether the independent variables are linearly dependent or not. Clear?
Yes, we are.
Yes, we
Yes,
are.
भैया.
Yes, Bhaiya.
And why is this a problem, guys?
Because it will hinder with
Because
the
beta 1, beta 2, beta 3, their interpretation won't make any sense. Yes or no, everyone?
yes,
हाँ
Bhaiya.
भैया.
Yes, Bhaiya.
Yes. There's one more reason, which I'll come to when we are diving deep into multicollinearity. And one way to measure linearly dependent is how? Correlation.
correlation.
So Pearson's correlation coefficient can actually be helpful to tell you whether the independent variables are have multicollinearity or not. Clear, everyone? And if a change in x1 is causing a change in x2, then that means there is a problem. Yes or no?
Yes, we are.
हाँ भैया.
Yes,
My
Bhaiya.
variables will lose my coefficients, my learnable parameters will lose interpretability. And when that happens, that means my model is shit. पता नहीं सौरभ क्या बना रहा है इंटर्नशिप में. सौरभ ये बना रहा है.
No, भैया.
All right, so that means my models are shit. And hence the assumption no multicollinearity. What is collinearity? Whether the independent variables are linearly dependent. No multicollinearity means there should be none of the independent variables should be linearly related. Clear, everyone?
Yes, भैया.
Yes,
Yes,
Bhaiya.
we are.
Yes,
Yes,
Bhaiya.
भैया.
Interesting. Now, what does assumption brings? It brings problems. What do problems brings? It brings solution in form of VIF. Soon learn later. Can I move forward?
Yes, Bhaiya.
Okay, very interesting one. Additivity. All right. So what this one says is what you just learned. Effect of one unit. यार ये पहली बार मतलब तुम्हें समझ भी आ रहे हैं कि अब क्यों रीजन है ये सब क्यों assumptions में है या मजे में आ रहा है बस.
नहीं हो रहा है भैया कनेक्ट.
फील आ रही है ना.
हाँ भैया.
YouTube से तो नहीं पढ़ रहे हो ना. Effect of one unit change in a dependent variable on the value of independent variable is what? is constant. Irrespective, थोड़ा सा अलग है, of the value of other independent variables. पहला वाला क्या बोल रहा था guys? First one was saying, what was first one saying, everyone? The assumption that we learned that beta 1 is what? Is increase in y or decrease in y, change in y basically, on 1 unit change of x1.
Yes, bhaiya.
Yes, bhaiya.
Assuming that all the other constants.
Assuming other are constant. This is what we learned earlier. Yes or no, everyone?
Yes,
Yes.
bhaiya.
Yes, भैया.
Now, let me explain you with an example. What should be the change in y when value of x2 is 100 and value of x2 is 10? On increasing x1 to x1 plus 1. This is first case, this is second case. What should be the change in y, guys?
Beta 1.
Beta 1.
Beta 1. See.
Same. The change in y will be beta 1.
Yes, bhaiya.
The change in y will be beta 1. 1 or 2 are same and equal to a constant beta 1. That is what the additivity law is saying. Effect of 1 unit change in dependent variable. Effect of 1 unit change in x1 on the value, effect of change in 1 unit of change in dependent variable. Now the effect of it on the independent variable is constant. Yes or no? Yes or no?
Yes, भैया.
Yes, bhaiya.
Irrespective of
Yes.
what? Irrespective of
Other
value
variable
of
data.
other independent variables. Does not matter whether it is 100 or 10. The answer will always be beta 1. Yes or no?
Yes,
Yes,
भैया.
bhaiya.
Otherwise, what will happen, everyone?
It will affect the interpretability.
Definitely, it will affect interpretability. And if you are not following this assumption, then you are saying that my beta naught, beta 1, beta 2 until beta k, if there are k independent features, then you are saying that they will change depending on the value of others. Is that true? Is that true?
In LR, no.
All right.
No.
Everywhere, no, Vedant. Weights 1 described never change.
Yes, bhaiya.
So now is it clear, everyone, why this assumption? I know it might sound very stupid after looking at this, but it has so much meaning to it. Yes or no, everyone?
Yes, भैया.
Yes, भैया.
Yes or no, everyone?
Yes, bhaiya.
Yes, भैया.
So is additivity
Yes.
additivity clear?
Yes,
Yes,
भैया.
भैया.
Yes, bhaiya.
Okay, now this is a little out of the scope. It's okay, we'll do it. Normality. अब ये मत पूछना क्यों चाहिए होता है क्यों नहीं चाहिए होता है, कभी बहुत वेले होंगे तो मैं पढ़ा दूंगा. This is not exactly needed. Nobody will ask you. This is actually maximum likelihood का एक concept होता है. So when you guys will do MLE, you will understand it. Not right now. Okay. But let's say this is only, ठीक है पहले पढ़ लो, जब लॉजिस्टिक पाएंगे तब बताऊंगा, लिख लो अभी के लिए. So normality says residuals. What are residuals, guys?
The difference between the actual and the
Difference between
Difference
actual
between
predicted.
actual and predicted values. of
Residuals should
dependent
follow a normal distribution. You will understand this when it comes to Emily. And I'll also tell you that this might not be valid for simple linear regression. Uh, okay, but not right now. We'll come to it later. Residuals should follow a normal distribution. Am I clear, everyone?
Yes, we
And
are.
what does that mean?
Yes, Bhaiya.
What does that mean?
Means in
If I plot, if my random variable is the value of residual, and this random variable would be what? Continuous. Yes or no? Yes or no,
Yes,
everyone?
Bhaiya.
So the probability of xi, the plot of this would be what? A continuous probability distribution.
Yes, Bhaiya.
Yes, Bhaiya.
And this plot of p of x, where my x is nothing but the value of random variables, and x the value of random variable, should be a normal distribution. Clear?
Yes, we are.
Yes, Bhaiya.
Clear, everyone?
yes,
Yes,
भैया
भैया.
Yes, Bhaiya.
Yes.
ऊपर एडिटिविटी में जो आपने डेफिनेशन लिखवाई है वो
ईशा,
हाँ
जब मैं
उधर
बोलता हूँ कि क्लियर है ना, तभी क्लियर किया करो.
नहीं नहीं
देखो
क्लियर
ऐसे ना
क्लियर
सबका
है
फ्लो टूटता है. हाँ बोलो अभी.
क्लियर है बस वो एक चीज
हम्म.
चेंज लग रही है कि इंडिपेंडेंट और डिपेंडेंट स्विच होना है मतलब इफेक्ट ऑफ वन यूनिट चेंज इन इंडिपेंडेंट वेरिएबल ऑन द
हाँ ठीक है, वो चेंज कर लेना यार. ये सब नोट्स में लिखा है, ठीक है ना? चेंज कर लो. इफेक्ट ऑफ वन यूनिट चेंज इन इंडिपेंडेंट वेरिएबल गाइस, नॉट डिपेंडेंट. उल्टा लिख दिया मैंने. कॉमन है मेरे को. देखोगे मुझे बहुत उल्टा सीधा लिखते हुए ये बार बार. इज इट क्लियर ना ऊपर का?
Yes, Bhaiya.
Is this point normality clear? Now, why residual should follow normal distribution? Don't worry about it. When we talk about maximum likelihood, we'll talk about it. Not right now. Okay.
Okay, we are.
Yes, Bhaiya.
Now, a very important assumption: homoscedasticity. Now, what exactly does homoscedasticity mean? Okay, it's not that easy to understand. It's okay. Variance of residuals is constant. That is homoscedasticity. So the assumption of linear regression is homoscedasticity. And the opposite of it, which is basically in terms of assumption, it will be no heteroscedasticity. Heteroscedasticity, spelling में हमेशा भूल जाता हूँ. हेट्रो ठीक है, इसको कुछ लोग इसको हेट्रोस्किडासिटी भी बोलते हैं, कुछ लोग हेट्रोसिडासिटी भी बोलते हैं. कुछ भी बोलो जो तुम्हारा मन है. कुछ बुक्स में हेट्रोसिडासिटी है, कुछ बुक्स में हेट्रोस्के है, हेट्रोस्किडासिटी है. एनीथिंग यू फील फ्री, यू कैन स्पीक. Really doesn't matter. Right? So no heteroscedasticity. What does heteroscedasticity means? Variance of residuals is not constant. Clear, everyone?
Yes, we are.
Yes, Bhaiya.
Clear, everyone? Now,
Yes, Bhaiya.
now, what does it mean that variance of residuals are evenly spread out? So basically, variance of residuals is constant or evenly spread out, or basically the residuals are evenly spread out. Or when you plot a graph, I'll tell you which graph, there is no funnel pattern. Am I clear, everyone?
Yes, we are.
Clear, everyone? Okay. It shouldn't be clear. बोलो ना,
So
नहीं
this
समझ
is
आया.
heteroscedasticity. So this is heteroscedasticity.
No,
कि
no, no,
the
no,
residual.
no, 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 no. Heteroscedasticity means variance is not constant, and the assumption is no heteroscedasticity. Opposite to heteroscedasticity means homoscedasticity. And yes, homoscedasticity should exist. Homoscedasticity means variance of residuals is constant. Opposite. Homosexual, अपनी
Yes.
बिरादरी के लोग पसंद करने वाले, constant. Heteroscedasticity, heterosexual, right? So variance
Yes,
of
bhaiya.
residuals is constant, is homo, and variance of residuals is not constant, is hetero. Variance of residuals is constant means residuals are evenly spread out. There is no funnel pattern. And this is what you should not understand. Are you able to understand?
No.
No, bhaiya.
So what does it mean? Now, why not? Again, when it comes to MLE, we'll understand. But for now, let's understand how to identify evenly spread or not. When you plot a graph of residuals versus Y predicted, then in this graph, these are the residuals. Do they look evenly spread out?
Yes, we.
Yes.
Evenly spread out. And that is homoscedasticity. Clear, everyone? Till here?
Yes, we are.
Yes, bhaiya.
Now, residuals Y predicted do the residuals look evenly spread out?
No, sir. No, sir.
No.
No, bhaiya.
So evenly by evenly spread out, you mean there is no funnel-like pattern. This is a funnel-like pattern. Funnel है ना भाई, ये ड्रॉ करके दिखाओ.
नहीं नहीं समझ गया ना भैया.
Everybody.
हाँ हाँ भैया.
Clear, bhaiya.
That means heteroscedasticity. The funnel can be all opposite side as well, guys. Okay. Like this also funnel can exist.
Yes, भैया.
Now a question to you. Very important question. Some of companies ask and none of the students get it correct. Is this the case of heteroscedasticity or homoscedasticity? This is residuals versus Y predicted.
Hetero.
Homo.
Homo. There's no funnel.
There's no funnel. So residuals can increase or decrease. That's completely okay. That means that your best fit line is performing very poorly for high Y values. That means you can improve the model because it is very linear in this case, right? But this is completely fine. This is homoscedasticity. There is no funnel-like pattern. What is this, guys?
Hetero.
Am I clear what is hetero, what is homo?
Yes, boy.
Yes, bhaiya. Yes.
What is this?
Hetero.
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 Wow. Clear, everyone?
Yes, भैया.
Yes, भैया.
अब तो गलती नहीं करोगे
Yes,
ना
भैया.
यार.
नहीं भैया.
एक ही लेक्चर में सारी गलतियां समझ में आ रही
कब की? कौन से जिंदगी जमाने की गलतियां?
है। पिछले 6 महीने पहले आई गेस, 6 महीने तो नहीं, सेकंड ईयर की।
सेकेंड ईयर में ऐसा क्या किया था?
भैया यही पढ़ रहा था मैं, पता ही नहीं चलता था क्या है, और उसमें
अच्छा।
कुछ भी कॉन्सेप्ट बना लिए फिर तो।
भैया
हाँ,
ये वेरिएंस ऑफ रेसिडुअल इज कांस्टेंट का मतलब नहीं समझ आया, मतलब वेरिएंस कांस्टेंट कैसे हो सकता है, ऐसा फील नहीं आया।
बेसिकली क्या कहने का मतलब होता है ना कि ये जो y प्रिडिक्टेड है ना अपना, इसके अक्रॉस जो तुम देख रहे हो ना, ये स्प्रेड, this spread across y predicted is even. You see for this, the spread is less. You see for this, the spread is increasing. Yes or no?
ठीक है,
Clear, everyone?
हाँ
Yes,
clear.
भैया.
यस भैया।
Yes, भैया.
So it's actually basically the spread is increasing for y predicted. And in a few textbooks, instead of y predicted, they can take any dependent variable as well. That is also true. Instead of y predicted, you can take any dependent variable as well. Clear? That also works.
Yes, भैया।
Yes,
Okay.
भैया.
Clear, everyone?
हाँ भैया.
यस भैया।
Feel आ गई?
हाँ भैया।
थोड़ी थोड़ी.
अभी थोड़ी आएगी, एमएलई में आएगी मेन तो. All right. Now there are a lot of problems. Can we start solving a few problems?
Yes, भैया.
Cool. Then let's solve. First problem was what, guys?
Linearity.
Linearity.
Good model. Tattoo model, right? You will not get
Yes,
this model.
भैया.
Basically, model will be like this. Bad model, right? So now, what should we do? What should we do?
Dimensional reduction.
Why do I do that? Why do I not just simply say for the first case, for the second case, can I say this?
यस भैया।
Yes, भैया.
Now, the problem is people think that now the model is working on higher degree of polynomial. Wow, that's not what is happening. You have done a good job by saying that don't work on x1. That's not what it is dependent on. It is actually dependent on x1 square. So take x1 square as the new feature or the independent variable. Am I clear, everyone?
Oh.
यस भैया।
Your
Yes, भैया.
model does everything the same. Your model doesn't change anything. But your new variable is just an x1 square. And that is how you're extending linear regression to polynomial regressions. Am I clear, everyone?
Yes, भैया.
यस भैया।
Your model will not treat anything differently. All the processes and everything is just the same because it is just another new feature for the model. Am I clear, everyone?
Yes, भैया.
Now, what are the different ways of how you can create a polynomial regression? One, by taking a new feature as x1 square, x1 cube, something like this, raised to the power 4, 1 by 2, something like this, yes or no? 1 by 3, 1 by 4, square root, cube root. Another way is by combining multiple independent variables in any format you want. Clear, everyone?
भैया ये सेकंड मतलब समझ नहीं आया. Combining.
You have two variables, x1, x2. You just multiply these and create a new variable, x1, x2. And then you say y is dependent on beta 1 of x1. Clear now?
Here. Here भैया.
Clear, everyone?
Yes, भैया.
Yes, we
So
are.
polynomial
Yes,
regressions,
भैया.
you don't have to study on them separately. I hope you understand that it's just a change of feature. The model is performing in the same manner. Am I clear, everyone?
Yes, we are.
Am I clear? In doubts?
No, भैया. No, भैया.
Rest of you, any doubts? Bhajan Kirtan is over. Manisha,
Clear भैया.
Vipul, Rajgopal, Rishabh, Urvashi, Saurabh, Priyanjali, to
हाँ
bol hi
भैया
rahi hai. Neha,
No
Neha, you sleeping today?
No, bhaiya. No, bhaiya.
Good morning, Neha. How was the nap?
No, bhaiya, I'm not sleeping.
Right.
भैया
Any
शायद मेरी
doubts?
आवाज नहीं जा रही होगी.
आ रही
Earbud
है
लगा
सब आ रही है
था.
आ रही है. Any doubts, anyone? Moving forward.
Bhaiya, one doubt.
Yes.
Okay, भैया.
Yes.
What do you mean by model is performing in the same manner, unchanging the feature?
A lot of
Wouldn't
people
the
think, that model learns differently, that the training happens differently. No, all the processes that you follow for a normal multiple regression model, the same happen for polynomial regression model. The only difference is that you have changed the feature and made a new feature. That's it. That's all. Apart from the feature change, there is no change in training, there is no change in testing, nothing changes. Clear, Mahesh?
okay? But accuracy will change, right?
Accuracy will change, definitely, but that is the goal, right? That is why you're doing it. I'm not saying, Mahesh, that these two are same. I'm not saying that these two are same. What I am saying is that you just give it a new variable. These two are trained the same way. They are tested the same way. They are validated the same way. All the assumptions are similar. Everything is same. Just the value of beta naught and beta 1 will become different. And they too will plotted in the same manner only. This one will be plotted with x1, with x1, and this will be plotted with y and x1. They will both be linear only. Only the feature changes. Clear now, Mahesh?
Yes, certainly.
Clear? Now, how do you make it difference is the hidden trick that you use by saying, hey, hello, actually this was y and x1 square, and my model is not linear. Okay? But it trains its assumptions, its testing, validation is as if it is being trained on linear data only. Clear, everyone? There is nothing changed in it. Clear?
Yes.
As if it is being trained on a data that has a linear relationship. And that is what you did by taking x1 square as x1. You said, hey, don't worry, this is linear relationship. Build a model. You're just saying that take this new feature, this is linearly related, and the model will be good. Clear, everyone now? Is this point clear?
Yes, we are.
Okay. So what I mean is not that these two are same, that beta naught for this and this will be same, beta 1 for this and this will be same, accuracy will be same, bias and variance will be same. No. What I'm saying is the way the linear regression model and polynomial regression model train are the same. Their back propagation, if people know what back propagation is, in gradient descent, I'll come to it. The way their coefficients are calculated, it's the same. Their assumptions are the same. Everything is the same. Only these change. And if you plot the exact graph of the new feature x1, that is x square, x1 square, and this one, both of these graphs will be linear as well. The graphs will be different, but both will be linear. How is it bringing non-linearity? Is because x1 is hiddenly x1 square. Is it clear, everyone? Now?
Yes, we.
Yes, Bhaiya.
Clear, everyone?
Yes, we.
Yes, clear.
So what I want to tell you is polynomial regression is not a hawa. Polynomial regression is just an art by you guys, by me, by other data scientists, and by other data analysts who say, nice, I can convert my non-linear feature into a linear feature and get good results. It's a smart move. But it is not as easy as you guys think of. Because in real life, understanding which degree of polynomial the linear regression will follow, whether it will follow x1 square, whether it will follow x1 4, whether it will follow x1 root, this is again an art. Or whether it will follow x1 and x2 is again an art. You need to hit and try to find out. There is no straightforward way. Clear, everyone?
Yes, we are.
Yes, we.
Yes,
Yes.
Bhaiya.
Yes, we.
So not a lot of problem is being solved here, but at least you know how we can convert linear regression to solve non-linear things, right?
Yes, Bhaiya.
Cool. Now, let's understand the degree of polynomial regression. What is degree of this polynomial regression?
Three.
Guys, 10th class maths, I think.
3.
The highest degree. So 3.
Highest degree is
Three.
3. Therefore, degree of the polynomial is 3.
3.
What about this?
Four.
Four.
What about this?
Four still.
Four.
Still 4. What about this?
Five.
Still 4. ये तो combine भी बन जाएगा। एक इसको तो आप बोल रहे थे कि combine कर लेगा।
क्या?
आप बोल रहे थे ना क्लब कर देंगे दो वेरिएबल्स को एक साथ।
हाँ तो क्लब ही तो होगा ना, ये भी मतलब क्लब का क्या मतलब है?
एक x बन जाएगा तो पावर फिर भी ऐड हो गया, दोनों अलग अलग है ना, तो पावर कैसे ऐड होगा?
ऐड होगा। तुम्हारा नया वेरिएबल तो यही बन रहा है ना, इसके कारण ही तो बन रहा है। इस वेरिएबल की भी तो डिग्री होगी ना कुछ।
चलो 5 होगी, 5 होगी।
ये भी तो एक वेरिएबल ही है ना भाई, इसी की तो डिग्री निकाल रहा हूं मैं। ऐसे ये भी तो एक वेरिएबल ही है, इसकी अपनी डिग्री है ना। यस और नो ऋषभ?
यस भी।
Is this point clear, everyone? Any doubts?
No.
Any doubts, anyone?
No way.
No way.
So what is a polynomial regression? It's a special case of linear regression. Here we don't use independent variables directly. They are either square, cubed, or multiplied together, and then we use it in a regression. And how we decide which polynomials we need to take, which degree of polynomial we need to take, it's a simple hit and trial method. There is no rule case for that. Clear?
Yes, please.
Yes, Bhaiya.
Clear, everyone? Any doubts?
No way.
No way.
All right. So in real life, data is quite dependent on each other, right? As we saw length and breadth.
Yes, Bhaiya.
Yes भी। Yes sir।
And almost every data in real life is quite dependent, yes or no?
Yes, sir.
So what should we do?
You would again have to feature engineer, I guess.
Good. So the solution is to only remove multicollinearity from the data. Yes or no?
Yes, we. Yes, we. Yes, we.
Let's say x1 and x2 are highly correlated. This model, whatever values of beta 1 and beta 2 it is giving, they're not correct. So you cannot say that because beta 1 is greater than beta 2, I will drop x2. That's not correct thing to say. Because the beta 1 and beta 2 are not interpretable, right? Yes or no, everyone?
Yes, we. Yes, we.
Yes or no, everyone?
Yes, भैया.
So again, either you do hit and trial, you drop x1, you drop x2, or you might go forward and combine x1 and x2 in any way you want. Any way you want. Am I clear, everyone?
Yes, we are.
Yes, we. Yes, we.
Yes, भैया.
So this rule of dropping is wrong. You cannot tell that, okay, I will see the feature importance and drop the one that is less important, because the beta 1 and beta 2 are not interpretable. You do not know you are doing the right thing or not. Yes or no, everyone? So it's a hit a trial. You either drop x1, you drop x2, or you combine these two and you see what is working best. For example, very commonly in machine learning, height and weight are combined into BMI. Clear? Clear, everyone?
Yes, we.
Yes,
Yes,
we are.
भैया.
All right. Now, what do I mean by highly correlated? Highly correlated over here, I mean Pearson's correlation, that is R, is close to 1. Clear?
Yes, we.
Now, a lot of people ask me, what should be the value of R so that I say there is correlation or not? What do you think the value of R should be? Say the correlation is there or not?
Greater than or greater than 0 or less than 0.
So 0.1 also you will say correlation is high. Huh?
हाई नहीं भैया थोड़ा बहुत.
Either close to 1 or -1.
All right, so only for 0.99 you will drop one variable. Otherwise, you'll say, no, go ahead. Model will be fine.
More than 0.5.
Okay, so you will say that, okay, 0.49 is wrong. It's not highly correlated. Okay, correct answer is nothing. Welcome to data science, guys. Your value of R to be greater than something, to say it is correlated or not, depends entirely on you. Nobody gives a damn. Am I clear, everyone?
Yes, we.
Generally, it is 0.5 in the magnitude. Clear, everyone?
Okay,
Yes,
we
we.
are.
So now I want to tell you a quick angle of data science and machine learning, basically AI. In AI, you cannot say that, oh, I will use R greater than 0.5 and my model will be the best out there. You cannot say that. Machine learning, AI, data science is an art. चलो कहीं तो मैं आर्टिस्ट हूँ. आर्ट आर्ट गाना वाना तो वैसे आता नहीं है, कहीं तो मैं आर्टिस्ट हूँ, राइट? So data science is an art in itself, right? थोड़ा बहुत पहले आता था गाना वाना तो छोड़ दिया गिटार बजाता हूँ कभी कभी टाइम पास
भैया
सुनाऊंगा तेरे को तो आ तू यहाँ पे तेरे से गाना बजवाता हूँ मैं पहले तो alright so it's an art there is no answer that is correct or wrong for a lot of things there is no definite answer for everything and that is why good data scientists are the ones who are very creative कुछ भी कर देते हैं कुछ नया बना देते हैं पता ही नहीं चलता ये कैसे किया they're very creative okay अपने बारे में नहीं बोल रहा हूँ मैं तो कोशिश करता हूँ क्रिएटिव होने की but yeah I still am creative no doubt in that I do a lot of creative shit in my office एक काम नहीं हुआ तो 2 लोगों को लड़वा दो what I did today jokes apart but yeah you need to think about art okay you need to have that angle of vision that everything is an experiment there is nothing definite it might work it might not work so whenever you're working as a data scientist or an analyst always work with a fail fast approach and show this to the people you're going to interview with that you follow a fail fast approach you do not 6 months waiting on something you rather would fail learn more reiterate and create something better okay
Yes, भैया.
I think in product it is called as I think waterfall approach or agile I think waterfall approach all right everyone is it clear
Yes.
so you got the angle now there are many variables one way to see if they are independent or not you can do what x1 and x2 calculate r1 r2 for them x1 and x3 calculate r1 3 for them x1 and x4 calculate यार बोल दिया करो हाँ समझ आ गया है लिखवाते मत रहा करो मजे मत लो मेरे r1 5 for them right then x2 and x3 calculate r2 3 for them
समझ ही गई.
clear
Yes, भैया.
how many r coefficients would you calculate pnc time guys
15 50
62.
62
15.
okay so 62 is correct guys sure Isha is this correct
जितने कॉम्बिनेशंस बनेंगे उतने ही आर निकालने पड़ेंगे.
हाँ तो पीएनसी पढ़ा है तो शोर क्यों नहीं बोल रहे हो
हाँ श्योर है.
इंटरव्यू पूछेगा कि शोर नहीं है तो तुम चुप हो जाओगे ये नहीं बोलोगे क्या आई एम प्रीटी श्योर guys get some confidence right if you know the answer you know it any doubts anyone
No, भैया. No, भैया.
so 62 times you will create r then you will have so many r1s r2s r3s to look at and after looking at these you will make a good decision
No, भैया.
the decision actually will not be a good decision anyways because when you remove these there might be cases that if you remove these some other variables start being correlated getting my point everyone
Yes, भैया.
getting my point and it might also happen that actually x1 and x2 were not x1 and x2 were correlated x3 was correlated and you decided to drop x2 x1 and x3 are still correlated you drop this one then you build a model on this one okay one case you can do that other case you can do drop this sorry keep this drop this so you're basically understanding how mad we will go doing all of this we keep this we'll drop this what to take how many hours to compare it's not a very easy thing to do right yes or no
Yes, भैया.
so we need something that kind of establishes a relationship. How about we establish the relationship, a linear relationship, nothing but a linear regression between x1, beta naught, beta 1 x2, beta 2 x2, 3, sorry, beta 4 x4 till beta 6 x6. Now, what does each variable tell me? What does each variable tell me?
The weightage of the variable in the model.
Tell me what will happen. So guys, is it not telling you basic linear regression concepts? This becomes my dependent variable. Any problem?
No, no.
Any problem? If I create a regression on this, it will tell me how does beta 1, how is beta 1 will tell me how x2 is affecting x1. This will tell me how x3 is affecting x1. This will tell me how x4 is affecting x1. Yes or no?
Yes, भैया.
Yes, we.
A good method? Yes or no?
Yes, we are.
Yes, we.
Okay. So we do certain sort of these stuff, and this is how we create a VIF. But VIF we'll cover after we have learned R square, because it's entirely dependent on R square. And without R square, you will not understand VIF. So there's no point doing it right now. Clear, everyone?
Yes, we.
Yes, we.
Okay. So now what is coming next? Let me tell you. So now what we'll do is we'll move to gradient descent algorithm in the next class. One second, let me have a look. We move to gradient descent algorithm. In next class, we'll try to cover gradient descent algorithm. After that, we will move to what is it called? One second. Different types of errors in ML. Basically bias and variance. Then we'll move to metrics for regression. Here you will guys understand this gradient descent algorithm will teach you how to compute results for multiple regression, polynomial regression. What all is left today? Clear, everyone?
Yes, we are. That's right.
Okay.
Yes, we.
Yes,
Errors in ML, bias and variance, very important topic. Then we move to metrics for regression. After metrics for regression, we move to VIF, and then we begin some problems in regressions. And once this is done, बीच में कहीं पे regularization आएगा. And after this, we have completed regression. Basically, the linear regressions, not all regressions. Clear? So regressions is long, it will take time, but it's 1/3 of your ML. Clear, everyone? All right.
yes, we can.
Yes,
Yes.
we.
And I hope you're able to understand how in depth I'm going explaining each and everything, because there is a reason that I'm doing it, because most of your questions are asked from this topic. Clear? इतना पढ़ लिया देखो आज हमने, और लग रहा है हमने पढ़ा है, but फील नहीं आ रही कि ज्यादा पढ़ा है. Getting my point? Yes or no?
Yes, we can.
Yes, भैया.
The problem is because we've gotten way depth into each and everything. So that is why I wanted to tell you that a lot of thing is coming, but we gotta be patient and be slow about it. Clear?
Clear, we are.
Yes, we can.
Clear, everyone? All right. So your homework for today is you need to go back and you need to complete your. You need to read linear regression. You need to just ignore VIF in there. Rest of it you can complete. Okay.
Okay. Okay, भैया.
Okay. Anything else?
No, भैया.
मेरा नेटवर्क डाउन हो गया था भैया, मल्टीकोलिनियरिटी के बाद वाला आई मिस्ड.
बस कुछ नहीं था उसके बाद मल्टीकुलिनियरिटी मैंने बोला कि ये हम तब समझेंगे जब हम VIF में कवर करेंगे, जब हम R square पढ़ेंगे. One way I explained was to calculate multicollinearity using Pearson's correlation coefficient. And I told that this might not be always the feasible way because of there will be many variables, and that is a problem.
Order n square.
And because of that, we'll go to VIF. So I just gave everyone a basic understanding of how VIF works. So I told them that every independent variable will be treated as dependent variable, and a linear regression will be made using the remaining independent variables. And then something will happen. Something more will happen. We'll get a VIF score, and then we'll understand that which variables are linearly related. But that we'll go when we are clear with R square. Clear, everyone?
Yes, भैया.
Yes भैया.
Yes, भैया.
Any doubts in today's lecture?
No, भैया.
In today's lecture, the assumptions are very important. Make sure you remember them. Every interviewer will ask you. In most of the exams, you will find assumptions from linear regression. So all these assumptions that I've taught you, make sure they are clear. And guys, you have understood a lot today. मेरे को लग रहा था कि आज हमने इतना ज्यादा कुछ नहीं सीखा है, but let's not forget we have also understood feature importance. We have also understood ये 100 रुपए का भेजा था मैंने जो यहाँ कॉपी हो गया है. अच्छा, you've also understood anyways. You also understood what? Feature importance. You've understood feature selection. So make sure you go through that. They are very important topics. Very important topics. हल्के लग रहे होंगे, but now I will not go into again the depth of feature importance and feature selection when we are dealing with other models. Am I clear, everyone? Am I clear?
Yes, भैया.
Yes भैया.
सेंस नहीं बनता ना इतना डेप्थ में जाके फीचर सिलेक्शन बताने का, फिर से समझा रहा हूँ, है ना? 10 बार एक चीज नहीं कर सकते, right? So make sure you do that. Then the next important thing was what we understood about multiple regression, the coefficient. How do we interpret the coefficient? Very important. Asked to me at least in 60% of the interviews I've so far sat for. Clear, everyone?
Yes, भैया.
Yes भैया.
Yes, भैया.
Then we understood a very tricky question, which you might go and trick your friends with. Family of lines and plane. मत बताना है दोस्तों को, guys. You gotta be a little selfish. It's मतलब ठीक है, I believe in helping others, but sometimes a few tricks should only be down your sleeve to get an edge over the others. अब सारे सक्सेसफुल लोग अपनी ट्रिकें सबको बताते चलते जाएं तो वो सक्सेसफुल ही नहीं बचेंगे. So it's okay to be a little selfish sometimes.
Yes भैया.
Okay. So apart from that, what we learned today was, yeah, we ended the previous lecture. Yeah, so I think everything we learned today is very important. Clear, everyone? Each and everything that we learned today is very important. There is not a single topic from today that I can say you can ignore. All these assumptions, heteroscedasticity, homoscedasticity, very important. Clear, everyone?
Yes, भैया.
Yes.
Yes, भैया.
Okay. So please, लग रहा है तुम्हें कि हमने कुछ नहीं करा है. मेरे को भी ऐसा फीलिंग आ रही है कि आज कुछ करा नहीं है. Maybe because we are back to 2 hours of classes rather than 3 hours. That might also be one of the reason. पढ़ना है क्या और?
नहीं भैया, 2 घंटे सही
नहीं
है.
भैया ठीक है.
हाँ, पढ़ोगे थोड़ी. जाओ.
फ्रीक्वेंसी बढ़ा देंगे ना भैया.
हाँ, frequency बढ़ाएंगे. No, the
ये सही
point
है.
was for SQL I took 3 hours classes because most of the time you guys were spending solving questions, right? So that is why the 3 hours classes. Ideally, if you would have looked at it, it would be 2 hours 45 minutes class. 2 hours 15, 2.5 hours. Baki 20-25 minutes you guys were solving questions only, right?
हाँ yes भैया.
Yes, भैया.
I don't want to continue that. That's why I'm ending today. And इसलिए मुझे फील आ रही है कि आज मैंने कुछ ज्यादा पढ़ाया नहीं है. पढ़ाया है ना मैंने? तुम लोग ही बता दो.
हाँ भैया मुझे तो
पढ़ाया
बहुत
ना
है।
भैया,
हाँ
स्क्रॉल कर रहा
भैया
है ना, पूरा
पाँच
स्क्रॉल
छह क्वेश्चन ऐसे ही सॉल्व हो गए
क्या कह रहा है सौरभ? स्क्रॉल करने पे
मेरे पाँच छह क्वेश्चन ऐसे ही सॉल्व हो गए.
कहाँ के क्वेश्चन?
मैंने कुछ क्वेश्चंस थे एग्जाम्स में मैंने गलत करे थे, वो सीधा सीधा दिख गया कि यार ये तो इतना आसान था.
तो अब सौरभ तू बात समझ रहा है ना जो मैं पढ़ाता हूँ? टेल एवरीवन एल्स that it is very
हाँ
important.
भैया.
And so guys, all this is very important. Ask why? Because सौरभ ने पता नहीं कौन से एग्जाम दिए थे. सौरभ पता नहीं कोई फर्जी एग्जाम बोलते बेइज्जती हो जाए बाद में. कौन से एग्जाम दिए थे ये बता पहले.
नहीं भैया, भैया डेटा साइंस
कौन?
से रिलेटेड थे.
डेटा साइंस से इंटर्नशिप वगैरह टाइम पे.
हाँ भैया.
So I hope you all understand that I'm not मजाक नहीं करता हूँ मैं जब बोलता हूँ कि all this is important.
हाँ भैया पता है.
यस भैया.
कुछ को पता है, कुछ अभी भी नहीं सुनते हैं मेरी. जाके अपने दोस्तों की सुनते हैं जो खुद कॉलेज में है, जिनको खुद नहीं पता वो क्या कर रहे हैं. Anyways, is it clear everyone? All this is very important, be it for your placements, for your internships, be it for your first job switch, for your second job switch, for your third job switch, till your last job switch. All this is very important, even at the time when your when your children will be born. Maybe one might be 2, 3, 7, 8, I don't know. I don't care. All right. So whatever it is, please understand that this is very important. I am spending time on regression for the same reason, because I don't want you all to not know any question in regression. You knowing regression in depth will give you a very good grasp, a very good hold on the entire concept of machine learning. And you're not understanding, but I'm teaching you so many things at once. I've taught you 2 to 3 methods of feature engineering. Yes or no? How to
Yes,
convert polynomial features into linear features I've taught you. I've also taught you how to feature engineer to include both the variables and still make a linear regression using help of feature engineering. Yes or no? Combining both the features. All this is nothing but feature engineering, guys. अब अलग से पढ़ोगे तो लगेगा हम फीचर इंजीनियरिंग पढ़ लें. मैं हर जगह बता रहा हूं, तो ये मत सोचना कि ये सब फीचर इंजीनियरिंग है. That is why I tell you feature engineering, feature selection, because all of this is nothing but feature engineering. Feature engineering is not like कि तुम कहीं नया डेटा पैदा कर दोगे. भाई अब जो है उसमें से पैदा थोड़ी कर सकते हो. कुछ जो है वो है, उसमें से नया डेटा पैदा नहीं कर सकते. But feature engineering is how you can combine, how you can manipulate, how you can select the best data or combine the best data or combine few or three data, whatever, to get the best data for your model. And that is what you all are learning. And again, there is no, sorry guys, but there is no such method that will help you know what to combine and not combine. If they're multicollinear, you want to keep both, combine them. How to drop them? There is something called as backward selection, which I will teach you. However, you already know one way to drop them, that is with the help of feature selection. Clear, everyone?
Yes, भैया.
Yes भैया.
यस भैया.
यस भैया.
भैया.
All right, anything else?
नो भैया.
No भैया. That's pretty true. Enough.
Nothing?
No.
नो भैया.